welcome to a lazy hangover Sunday here in the old shopperoonie. For fuck's sakes, don't kick the tripod. Pardon my French. Well, let's see. I was cleaning up the shop, but I got distractimated. So on one of the boards, somebody said that instead of using carbide, you can actually use high-speed steel, HSS, for flow drilling, for friction drilling. So I'm going to put a little chamfer on this HSS drill bit. I sacrificed a nice Walter for this, so it should be top of the line steel. We're going to give her a go. And of course, I got my safety glasses on, because apparently pokey things in your eyes don't do anything for your vision. Long term, anyway. I don't know about short term, blah, 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 blah. I got the custom dress on the wheel. She's got a little bit of a chamfer over this way, and also a divot like the surface of the moon, so should do real well. Oh yeah, won't go into gear, son of a... Oh, for fuck's sakes. Okay, we got the dirty cork stuffer's batteria all changed out. She should go like a hot damn now. And I noticed I'm running low on the tap water. Gonna have to go to Thomas Skinner and Sons to get some more of that stuff. And I found that it's good for cooling stuff off. It's not just for tapping holes. Milwaukee, look at this fucking piece of oh, yeah, of course. I had to spin it like 4 times to get it to unlock. Ah! Now this mill may not look like much, but I made a couple special modifications myself. Specifically, the speed control now goes to 11, because I put a sticker on it. If it goes. And that is not 11. And that is clearly a complete and utter fail of the high-speed steel. Myth busted. And I'm sorry to say that friction drilling, flow drilling, whatever you want to call it, drilling with high-speed steel is going into the beaker of shame. No worky worky. We're going to continue on with our friction drilling with a little twist this time. Now if you're anything like me, and you want to join 2 dissimilar metals, say high-speed steel and copper, then you got to go out to the shed and you got to drag out your bottles and you got to drag out your oxyacetylene torch and then you got to drag out your silver solder and you got to... Well, I'm going to try and do this with friction welding. Stick around. And for those of us who just crawled out from under a rock, you all know I'm all about the safety. Rotating components have an incredible amount of energy. So you're going to want to wear your safety glasses. Get your mother to supervise you while you do this. The plan here is I'm going to fire up the mill, run it at 11. I'm going to jam this down into the workpiece at about 200,000 RPM. Then when it hits a white hot heat, we're going to cut the power to the mill and hit the brake. Best case scenario, the 2 dissimilar metals weld together. Worst case, well, at least I left a beautiful corpse. Speed walk. I can hear some bacon sizzling. Something's hot. I was just blow on it. That should be good there. Okay, let's give her a little try here. Take her out of the wash. Ah! Son of a diddly. Well, that didn't work for shit. Well, I tried nothing and we're all out of ideas, so let's put some heat to the components, see if that helps. I had a nice little curl of something come up. Let's see if she took. Ah! Well, it looked nice and hot. Well, of course, the proof is in the pudding. Oh! It worked! It's welded! Now we have the world's most ill-advised boring bar. I don't know about you, but that seems to be about the strength of my typical welds. Thanks a lot for watching, guys. Keep your stick on the ice and watch out for them wooden nickels, especially on internets.